Now, we said that radioactive nucleus, unstable nucleus decay. Okay? And when they decay, they emit alpha, beta, and gamma particle. So how fast do they decay? Or how much do they decay? What do we know about how fast or how much is left over when they decay? Half-life is a measure of these questions. So if you look at this graph, we're talking about the number of days on the x-axis and amount of phosphorus 32 on the y-axis. So at the beginning of this experiment, there is 100% phosphorus, and then after 14.3 days you have 50% of phosphorus, right? After the next 14.3 days, as in from the initial it's 28.6, you have 28%, right? So now half-life written as T half. What does this mean? This means the amount of time taken for a sample to decay into half. So if you have 100 grams of a sample, then after T half time, as in after this much amount of time, it becomes 50 grams. Now, from this point, after another T half time, right, it becomes 25 grams. Okay, so for example, if T half of a nucleus is, say for example, 2 days. So you start with 30 grams of a substance. So your initial is 30 grams of a substance. After 2 days, you're left out with 15 grams of a substance. After the next 2 days, you're left out with 7.5 grams of a substance. So that means from the initial, after 4 days, 7.5 grams of the substance is left over. We will do problems about this in class.